Hello friends, in this video we will discuss the banker's algorithm which is used in deadlock avoidance in operating systems. So if we do not know what is a deadlock, then I have already recorded a video on what is a deadlock. For a brief recap, deadlock is a situation in which there are processes which are waiting for resources and there is no method in which any one of the processes can be satisfied with their needs so that the deadlock can be solved. The processes are waiting in a circular fashion, like P1 is waiting for P2, P2 is waiting for P3, and P3 in turn is waiting for P1 to finish, and none of them is finishing because each one of them is holding some resources which the other one requires, and therefore everyone is waiting for some other process in a circular order. This is a very important point of circular order. There are four crucial conditions of deadlock, which is mutual exclusion, hold and wait, circular wait, and no preemption. So if you want to refer to these points, please visit the previous video. And in this video, we will discuss the banker's algorithm. Banker's algorithm is used to find out whether we can solve the deadlock in the system so that whenever a process is going to request for the resources, the system will check if it will allocate these resources, whether the system will enter the deadlock or it will not enter the deadlock. So in this way, the system will try to find a safe sequence, that is in the order in which all the processes can be given the resources and their needs can be met. Therefore, no deadlock will occur. So if the safety sequence can be found out, then we will say that there is no deadlock is going to occur, and therefore we have avoided the deadlock. But if the safety sequence cannot be found, in that case there is a chance that the deadlock is going to happen, and therefore the system should avoid allocating such resources. So let us look at the details of the banker's algorithm. It is specifically useful when there are multiple instances of a single resource. So we can always look at the resource allocation graph where there are resources which have multiple instances. For example, there is a hard disk. So instead of a single hard disk, there are multiple hard disks, or there are more than one printers which are attached to the machine, and therefore there are multiple instances which the resource processes can use. Then each process is going to tell in advance what is the maximum resources it is going to ask for. So they have to tell whether how much disks, how many disks they require, how many printers they require, how much keyboard time, how much mouse time. So all the resources, files, etc., whatever the system is going to require, the process is going to require, it has to declare in advance. Then the process, it is going to request for the resources, and it has to wait also for the resources to be allocated. Now when a process will get all the resources that it requires, then it must return all the resources back to the system in a finite amount of time. That means after allocation of all the resources, the process should complete and terminate in a finite time and return all the resources which have been allocated to it. Now for the banker's algorithm, what we require is, so let us look at a scenario where we have a total maximum number of available resources. There are processes P1, P2, P3, etc. And each of these processes, they have told in advance what is the maximum number of resources they will require. So suppose there are three types of resources A, B, C, and each one of them has say 10, 5 and 7 instances in the system, and the process P1, it says it requires 3 of type A resource, and then 4 of type B resource, and 5 of type C resource. So that is the maximum need of the system. So there is a available vector. Available vector represents what all resources are available in the system. Then there is a vector. It is not a vector, it is a matrix, maximum. Maximum will tell you which process requires how many resources of each type and what is the maximum requirement that the process is going to have. Then we have the allocation, the resources which are already allocated to the process out of the maximum. So when you subtract allocation from the maximum, that will give you the need, that is what is the remaining resources that the system is going to require. So available is the maximum resources which are available currently. Then maximum is the maximum resources process is going to ask for. Allocation is what is already allocated to the process, and need is what it needs in the future. So these are the four data structures which are there, and generally in the question which is given by the examiners, available is given to you, maximum and allocation are given to you. You have to find out the need and then you have to find the safety sequence. So let us look at one example. Before that, let us look at the safety algorithm. Now the safety algorithm says there are two vectors, work and finish. Work is the total available resources in the system and finish is a Boolean vector. If it contains false, that means that particular process, if finish of 0 is false, that means the 0th process is not complete. And if finish of 0 is true, that means this process is already included in the safety sequence and therefore we don't need to worry about this process anymore. Then what we will do is we will find one process such that the finish is false for that particular process and its need, that means its requirement of resources, is less than equal to the work which is the available. So that what it means is we can meet this process's needs and we can satisfy its needs and it can complete and return what allocation has already been done to it. So what we will do is we will assume that since the need can be met, assume that the process is completed and whatever allocation was made to it, we add it back to the work and we mark the finish of that particular process as true. So in this way, we will continue here till all the processes will be marked as true. If in the end, all the processes are marked true for the finish, in that case, the system is in a safe state and we have found the safety sequence. And in case any one process is going to remain without getting finish is equal to true, that means that we cannot find a safe sequence for that particular given configuration. Now let us look at one example. Here it is saying that in the operating system there are three resources X, Y and Z, and they have also given the total number of resources which is 8, 5 and 4. X has 8 instances, Y has 5 instances and Z has 4 instances, and there are three processes P0, P1 and P2. Now for P0, the allocation, that is the resources already allocated, are given here. X is 0, Y is 0 and Z is 1. For P1 it is 3, 2, 0 and for P2 it is 2, 1, 1. Similarly, we have been given the maximum resources which have been allocated, which will be required, and that is given for each of the process for each resource. So this is a n by m matrix where n is the number of processes and m is the number of resources. Similarly, allocation is also a n by m matrix. So this information is given to us. Now what we will do is we will add the allocation of all processes. So like here we have, for this one we will have 1, 0 and 1. So 2. Then for Y we have 3 and for X we have 5. So 5, 3, 2 is the maximum number of resources which are allocated. So we will subtract this from the total resources which are available. So 8 minus 5 is 3, which we can see here. Then 5 minus 3, that is already allocated 3. So that will give us a value of 2. And 4 minus 2 will give us a value of 2. So this is the available resources. How we have calculated? We have added the allocation of all the processes and subtracted it from the maximum resources which are available in the system, and that will give us the currently available resources. Then we will find out the need of each of the processes. How we will find out? From the maximum we will subtract the allocation and we will get the need of all the systems. Like here we have 8 minus 0 will give us 8. Then 4 minus 0 gives us 4. 3 minus 1 will give us 2. Then here we have 6 minus 3 will give us 3. 2 minus 2 will give us 0 and 0 minus 0 will give us 0. Similarly, we will calculate for P2. So after we have found the need and we have the available with us, now we will see which process we can complete by making an allocation. So when we look at the process P0, it requires 8 instances of X, but we have only 3. That means this process cannot be completed. Then we go to process P1. It requires 3 instances of X. We have 3. Then for the other 2, it doesn't require anything. That means we can complete this process. So we will mark this process as completed. And whatever allocation was done to it, that is 3 to 0, we will add that to the available. And what we are going to get here is, we will get the available is going to change. We have 6 resources of type Y, we have 4 resources of type Y, and we have 2 resources of type Z. So this is the now current available. Now with this available, we will try to see if we can satisfy the process. So we will move in a particular cyclic order so that we don't disrupt the order. So we come here to the third process, and here in this we have 6, 4, 2 resources, and we need only 1, 2, 2. That means this can be completed. So we will mark it as complete. And then we will add the allocation which was done to this process. So 211 will be added to this currently available. So what we are going to get is, when we will add 211, we will get 8, then 4 plus 1 is 5, and 2 plus 1 is 3. So these are the available resources, and then we can meet the requirements of the process P0, so that is going to complete. So the process P1 completed first, then P2 completed second, and P0 completed third. So this is the safety sequence in which we can execute all the processes, and therefore the system is not in a deadlock state. So similarly, we have to find out from the allocation and max, we will find out the need, then we have the total number of resources, then we find the currently available resources, and then we try to satisfy the need with the available resources, and we keep on adding the allocation of the process that is going to complete. And in the end, all the processes, if they are getting executed comfortably, then we will say the system is safe. Otherwise, the system is not in a safe state. So I hope this video is useful to you. If you like my channel, please subscribe to my channel and share the videos with your friends. Thank you very much.